Thanks, everyone. I think even by BigMathsJam standards, this must be a bit of a silly title. But it does have a bit of an origin story. It got started when my kids became obsessed with this video called The Mystery of the Squarest Country by the Map Men. I don't know whether anyone's seen it. It's more compelling than I'm going to make it sound because I'm going through it quickly. They basically go through almost every country in the world saying why they're not square before they get to a very small list of countries that they think are reasonably square. They declare that Egypt is the squarest, but they don't give any definition of squareness. They don't give any methodology. They don't give any quantification. And I think we deserve better. So I came up with my own definition of squareness. I said, pick a square. A relatively good square. We find two kinds of error. There are bits of square that's outside the country and bits of country that's outside the square. So we've drawn all of that in red here. We add it all up, divide by the area of the square. All we need to do is to pick the square that is best at this, that minimizes that ratio. The first approach that I thought of, the kind of brute force way, try all the squares, was going to take 100 million years. Now, Matt Parker famously points out, as long as it's less than the age of the universe, that's okay, right? But I only had 2 weeks until BigMathsJam, so I did have to do better. Came up with an iterative algorithm. It was fine. I could have ended the whole thing here. I can quantify how square a country is. But there's one thing that was bugging me. Along the way, they criticized Nauru as being nearly a circle. Now, I don't know. Is it nearly a circle? I don't think it's that circular. But it got me wondering, is being a circle actually bad when it comes to being a square? By my definition. So let's try to use a definition to figure out how square a circle is. So imagine we've got a unit circular country. We need to pick the square. So the only thing we need to choose is the side length. Call it 2x. We add up all the orangey errors there. We get this lovely looking integral. When you take that integral, divide by 4x squared being the area of the square. Take the derivative, set it to 0, all the usual. We feeling good about this? I wasn't feeling too good about this. So a new plan, because it's only the ratio we care about. I can rescale every frame however I like. It's not going to change the ratio. So let's hold the square constant size and change the size of the circle. All I need to do now is minimize the red area, because my division doesn't matter. I'm dividing by a constant. Now, if you can see, I don't know whether it's big enough, the yellow arcs there are the bits that will stop being error when the circle gets bigger. The blue arcs are the bits that will stop being error if we make the circle smaller. So in order to make the error as small as possible, a little bit of visual calculus here, it actually happens when the yellow arcs and the blue arcs are exactly the same length. In other words, we've got 8 slices, all of exactly 45 degrees. So we're nearly there. We just need to actually work out the error ratio for this thing. So focus on just one little 45-degree slice of the whole thing. The error ratio within this diagram will be the same as in the big diagram. So separating it out, we've got a green triangle minus a blue wedge, plus a blue wedge minus an orange triangle. Those are the two sources of error of the two kinds. But the good thing is we know that all of our wedges are the same size, because they were all 45 degrees for the full-size wedges. So the total error turns out to be a green triangle minus an orange triangle. At this point, I'm panicking, because I know it's important to include pi in my talk, and my pi's are vanishing. But I must press on. So the error ratio is the green minus the orange divided by the green plus the orange. To work this out, because these are 22.5-degree angles. Who knows trig functions of 22.5-degree angles? Anyone? Not me either, I don't know. So again, I was feeling gloomy at this point. But if you look back at the original triangle, the hypotenuse is root 2 times the base, which means we can just use a little bit of sine rule, and it means that the area of the green triangle works out as root 2 times the area of the orange triangle. So the angles are the same, they've got one side in common. We can plug those values in, and we do get an answer for the squareness of a circle. Simplify it. If we want a number which is bigger for more square, we can take 1 minus the error ratio. Squareness is 2 root 2 minus 2, or about 82.8% square. That is how square a circle is. Now we can compare it to the countries. And what we find is, indeed, they were right. Egypt is the squarest country. Shame they didn't give the methodology, but they were right. But Circle Land comes a very, very close fourth, only 0.5% worse than Côte d'Ivoire and about that compared to Sudan. So don't knock circles for not being square. They're actually squarer than you think.